In this video, we're going to go over solving equations in one variable. There are essentially three different types of these equations. We have one-step equations, which are exactly like they sound. They can be solved in only one step. Then there are two-step equations. These are going to need two steps to be able to solve. And finally, we have multi-step equations. These would be any of our equations that require more than two steps in order to solve. Let's start with the one-step equations and go ahead and take a look at an example. So here in this example, we have x minus 18 is equal to negative 1. Before we start, we need to go ahead and identify what is the variable that we want to isolate. Our variable is this x right here. We want to get him by himself. Right now, there is something preventing him from being by himself, and that is that negative 18 right there. So to get x by itself, we want to get rid of that negative 18 and send him to the other side of the equal sign. To do that, we're going to do the opposite. So here we have a minus 18, so we would need to add 18 to both sides. When we do that, we still have our x, and we have a negative 18 plus an 18, which is going to equal 0, which cancels out. We have our equal sign, and we have a negative 1 plus an 18. So that is going to give us a 17. Let's look at another example of a one-step equation. In this example, we have 0 equals negative 2 plus x. So again, we first need to identify what is the variable we want to solve for. In this instance, our variable is that x right there that I've highlighted in yellow. We need to see what is preventing him from being by himself. In this instance, it is that negative 2 right here that is preventing him from being by himself. So how are we going to undo a negative 2? We're going to do the opposite. So in this case, we're going to add 2 to both sides. So we get a 2 is equal to a negative 2 plus 2 becomes a 0, so that cancels. And we're left with our x. So we have our final answer of x equals 2. Let's look at another example of a one-step equation. So here we have a 20 plus an x is equal to 32. Again, we need to identify the variable we want to isolate or we want to solve for. And again, it's that x right there that I've highlighted in yellow. What is preventing him from being by himself is this 20 right here. That is keeping my x from being by himself. So we need to send that 20 to the other side. So we do that by using the opposite function, the opposite operation. So if we have a positive 20, we're going to send him to the other side by subtracting 20 to both sides of the equal sign. So a 20 minus a 20 gives us a 0, which cancels out. So we're left with an x is equal to 12 for our final answer. Let's look at one more example. So here we have a 5 plus x is equal to negative 11. Again, figure out what is the variable you're going to solve for. That's that x right there. What is preventing him from being by himself is that 5. So we need to send that 5 to the other side. We do that by using the opposite operation. So the opposite of a positive 5 would be to subtract a 5 from both sides. So then we have a 5 minus a 5, which gives us a 0, so that cancels out, leaving us with an x is equal to negative 16. So far, all of our examples have dealt with using either addition or subtraction to solve. That is not always going to be the case in one-step equations, so let's look at a different type of example. So here we have a 15v equals a negative 60. Process isn't really going to change. You still need to identify what are you trying to solve for. I'm trying to solve for that v. That is my variable. Right now, what's keeping him from being by himself is that 15 that is being multiplied by him. So I'm going to go ahead and do the same thing. I'm going to use the opposite operation. The opposite of multiply is to divide. So we need to go ahead and divide both sides by 15. When we do that, 15 divided by 15 equals 1, so those are going to cancel out, leaving me with, on the left, a v is equal to a negative 60 divided by 15, which gives us a negative 4. Let's look at another example involving multiplication. Here we have a negative 320 is equal to a negative 20. Well, what is the variable I'm trying to solve for? It's that x right there. What's preventing him from being by himself is that negative 20 that's being multiplied by it. So I need to go ahead and divide both sides by that negative 20 so that I get the x by itself. So here on the left, I get a negative 320 divided by a negative 20, which is going to give us a 16. And then on the right, we have a negative 20 divided by a negative 20. That's going to divide to equal 1, so it's going to cancel out, leaving us with just our x. So our answer is that x is equal to 16. Let's look at another different example. Here we have 5 is equal to, oh no, a fraction, an n divided by 11. Fractions are just division. No need to panic. We still need to identify what are we trying to solve for. I'm trying to solve for that n, which happens to be in the numerator. Right now, he is being divided by an 11. That is what is preventing us from having the n by itself. So how do you undo divide by 11? Well, you use the opposite operation. So I'm going to multiply both sides by 11. So on the left, that's going to give us a 55. And on the right, we have an 11 in the denominator and an 11 in the numerator. Those divide out to equal 1, leaving us with our n by itself for our final answer of n equals 55. Let's look at one last example dealing with one-step equations. So here we have a negative 3 is equal to an x over 20. Again, who are you trying to solve for? You're trying to get that x right there by himself. What is preventing him from being by himself? That divide by 20 right there. So how do you undo divide? Multiply, correct. So we're going to go ahead and multiply both sides by 20. On the left, that is going to give us a negative 60. And on the right, we have a 20 divided by a 20 that divides to equal 1, which cancels out, leaving us with just our x. So we arrived at our final answer of an x equals a negative 60. Okay, so that's enough examples of one-step equations. Let's take a look at two-step equations. So here in this one, we still want to figure out what is the variable we want to solve for. And that is that p. So we do the same thing we were doing in one step. What is preventing him from being by himself? So right now we have this guy preventing him and this guy. Since that 20 is part of a group with the p, we're going to deal with that 7 first. So how do we send a 7 to the other side? We're going to do the opposite of addition, which is to subtract. So now I still have my p over 20, and now it is equal to a 1 because a positive 7 minus a 7 is a 0, so those cancel out. So that's how we arrived at our p over 20 is equal to 1. Well, we haven't reached our goal. Our p is still not by itself. I still want to get that p by itself. Now what's preventing him from being by himself is that divide by 20. You undo division by multiplying both sides by 20. A 20 divided by 20 divides to equal a 1, so they cancel out, leaving you with a p is equal to a 1 times a 20, which is 20. Let's look at another example. So here we have a negative 5 minus 10m is equal to 85. We're still doing the same thing. What is the variable I'm trying to solve for? That m. So I need to get rid of that negative 5 first. So I undo the negative 5 by adding 5 to both sides. So a negative 5 plus 5 is going to cancel out. That equals a 0. Leaving me with our negative 10m is equal to 90. Now, again, we still don't have that m by itself. So right now it's being multiplied by a negative 10. The opposite of that is going to be to divide by negative 10. Negative 10 divided by negative 10 divides to equal a 1, so it cancels, leaving us with an m equal to 90 divided by negative 10, which is a negative 9. Let's look at another example. Here we have a b plus 7 being divided by 5, all equal to 2. Well, what do we want to isolate? We want that b by himself. Right now, 7 is being added to him, and then that total is being divided by 5. So we first have to get rid of that 5. So how do we undo divide by 5? We multiply both sides by 5. So on the left there, a 5 divided by a 5 is going to divide to equal a 1, leaving us with our b plus 7 is equal to a 2 times 5, which is 10. We're still trying to isolate that b. So we have a b plus 7 equal to 10. How do we get rid of that plus 7? We're going to subtract 7. So we get a b, the plus 7 and the minus 7 equals 0, so it cancels out, is equal to 10 minus 7, which is 3. Let's look at one last example of a two-step equation. So again, we're doing the same process. What do we want to isolate? We want to isolate that variable, that n. So in order to get rid of that, first I need to get rid of that negative 8. How do you undo a negative 8? You're going to add 8 to both sides. So over here on the left, we end up at a negative 5 is equal to a negative 8 plus 8 equals 0, so that cancels out, leaving us with our negative 5n. We're still trying to isolate that n. We haven't done that yet, so how do you undo being multiplied by negative 5? You have to divide by negative 5. So negative 5 divided by negative 5 is going to give us a 1. Negative 5 divided by negative 5 over here divides to equal 1, and so we are left with our n. So n is equal to 1. Okay, let's move on to multi-step equations. So looking at this one, we've got a lot more going on than we did before, but our end goal is to isolate that v. Right now he is inside a parentheses, so how are we going to get rid of those parentheses? Those parentheses are indicating a distribution problem with that 8 being distributed to both. So 8 times 1 gives us 8. 8 times the negative 2v gives us a negative 16v. And we still have our plus 4 is equal to negative 100. We're still, again, trying to isolate that v. We have not done that yet, so we want to look to combine like terms. I have an 8 and a positive 4. Those are both numbers. I can combine them to get a 12. Then I still have my minus 16v is equal to negative 100. Now it's looking like our two-step equations. How are we going to get this v by itself? That's still our end goal. I need to undo that positive 12, so I do that by subtracting 12 from both sides. A 12 minus 12 gives us a 0, so that cancels out, leaving us with our negative 16v is equal to a negative 112. Again, we're still trying to get our v by itself. Right now it's being multiplied by a negative 16. So to get rid of that or to undo that, we're going to divide by a negative 16. Negative 16 divided by negative 16 gives us a 1, so we cancel those out, and we arrive at V equals a negative 112 divided by a negative 16, which gives us a positive 7. Okay, let's look at another example like that. So here we have a negative 86 is equal to a negative 6 being multiplied by an n plus 8, and then subtracting 8. Again, we're still trying to isolate our variable. Our variable's right there. How are we going to get rid of those parentheses? That is a distribution problem. We're going to take that negative 6 and distribute it in. On the left side, I haven't changed anything, so I'm just going to drag him down here, leaving him the same. Negative 6 times n gives us a negative 6n, and a negative 6 times 8 gives us a negative 48, and we still have our negative 8. Now we can look to combine like terms. I have a negative 48 and a negative 8. Those are both numbers. We can combine them. So we have a negative 86 equals a negative 6n, and then those combine to give us a negative 56. Now again, it looks like our two-step equations, our two-step problems. We're trying to get that n by itself. I have to send that negative 56 to the other side. So I do that by adding 56 to both sides. That's going to give us a negative 30 on the left is equal to a negative 6n, because a negative 56 and a positive 56 add together to give us 0, so that cancels out. I'm still trying to get that n by itself, so now I need to divide both sides by a negative 6. So on the left, negative 30 divided by negative 6 is 5. Negative 6 divided by negative 6 divides to equal 1. That cancels out, leaving us with our variable n by itself for a final answer of n equals 5. Let's look at one last example before you start practicing these on your own. Here we have a negative 294 is equal to a negative 7 times a 7 minus 7b. Again, who are we trying to isolate? We're trying to get that variable b by itself. That negative 7 is a distribution problem, so we're taking that negative 7 and distributing it to both of those terms. So we have a negative 294 is equal to a negative 49 and a positive 49b. Now from here, we need to, again, who are we trying to isolate? We're trying to isolate that b. That negative 49 is preventing it from being by itself, so let's send that negative 49 to the other side by adding 49. So negative 294 plus 49 gives us a negative 245, and that is equal to negative 49 plus 49 is equal to 0. That cancels out, leaving us on the right there with a 49b. Again, we're still trying to isolate that b. What's keeping him from being by himself is that 49. So how do you undo a multiply by 49? You have to divide both sides by 49. So on the left, negative 245 divided by 49 gives us a negative 5, is equal to 49 divided by 49 is a 1, so that's going to cancel, leaving us with just our variable b. Final answer of b is equal to negative 5.